In stats, we've been doing one proportion z intervals. And let's look at how the formula chart works and look at that critical value I was talking about. Here's page 1 of your formula chart. And look at the very bottom of it. Right here, we have a very generic formula for confidence intervals. Right there. Our formula on this section is p hat plus or minus z times this. If you flip to the next page, at the very top right, you see the standard error. Right there. But nothing tells you it's z. So back here on this generic formula, you just need to memorize that if it's a proportion problem, we're going to be using z. Now, the calculator does it all by itself. You know, you click one prop z interval and it does it. But sometimes there's backwards problems where it's handy to know where to get these z values. Like, what is it doing? If you go, well, first, it's talking about when you do this confidence interval, we're trying to estimate p, which ideally is right here, you know, the mean of the thing, the sampling distribution. And what the calculator does is it factors in that 5% rule if you choose to do a 95% confidence interval. So it's referencing the middle 95%. On the z curve, that's 1.96. If we wanted a 90% confidence interval, it'd be a little different. That would be 1.645 and negative 1.645. So the calculator's getting that by doing inverse norm and getting the percentile at that far end. So remember, if we're talking, let's look at the 90%. If we're talking about 90%, that means to make the calculator give me 1.645, I need to type in this area right here. And if the middle area is 90, doesn't that mean that this tail, the dark green, the dark green, is 0.05? And this tail is 0.05, and the middle is 0.9, right? So on the calculator, I need to type in 0.95, and it'll give me 1.645. So I go to Menu, Stats, Distributions, Inverse Norm, and I type in 0.95, that's not a 95% confidence interval, that's a 90% confidence interval. It gives me 1.645. Because it has to add that left tail, and it's referencing a middle 90%. Another way to look at it is to go to Table B, and it's all done for you. Here's Table A. Table A is never ending. Table B is 2 pages long. We'll look at these here soon. These are t values. And if you read this table bottom up, so this is page 2 of Table B, if you read it bottom up, these are all confidence levels here. All of these are confidence levels. These right here are critical z-scores or values, the infinity row. And notice 90% is 1.645. 95 is 1.96. Another common one is 99, which is 2576. So they may throw you a curveball on a multiple choice and say, what's the critical value for 96%? And then some people panic and they're like, I don't know how the inverse norm thing works, but look, it's printed for you right here. Now, we're going to need to use all these numbers up here eventually when we get to means, but for proportions, it's very simple. Use that bottom row. All right. One more time, this is referencing a middle area, and that's why on inverse norm you have to take into account the left tail to get that number out right. But just use the formula chart. It's already done for you. It's all right there. All right, hope that made sense. See y'all later.